Welcome. Today, we're diving into the world of edge computing, a technology that's changing how data is processed and delivered. In a world where devices are everywhere and data is generated at lightning speed, edge computing brings computation and data storage closer to where it's needed, rather than relying solely on distant data centers. This approach is transforming industries from healthcare to transportation by enabling faster responses and reducing network congestion. Let's start by understanding what edge computing really means and why it's becoming so important in our increasingly connected world. Edge computing is a distributed computing paradigm that processes data near the source of data generation, rather than sending everything to a centralized cloud. Imagine a network of sensors in a factory. Instead of sending all sensor data to a remote server, edge devices analyze and act on data locally. This reduces latency, saves bandwidth, and allows for real-time decision-making. Edge computing is especially useful in scenarios where immediate action is required, or where sending data to the cloud is impractical due to bandwidth or privacy concerns. Why is edge computing such a big deal? As more devices connect to the internet, think smart homes, autonomous vehicles, and industrial machines, the amount of data generated is skyrocketing. Traditional cloud computing can't always keep up with the demand for instant processing. Edge computing steps in to handle data locally, reducing delays and making systems more responsive. This is crucial for applications like self-driving cars, where split-second decisions can make all the difference. It's important to understand the difference between edge and cloud computing. Cloud computing relies on powerful centralized servers to process and store data. Edge computing, on the other hand, brings computation closer to the devices generating data. While the cloud is great for large-scale storage and analytics, edge computing excels at real-time processing and reducing the load on networks. Many modern systems use a combination of both, leveraging the strengths of each approach. Edge computing works by deploying small, powerful computing devices, often called edge nodes, close to where data is generated. These nodes can be sensors, gateways, or even smartphones. They process data locally, filter out what's unnecessary, and only send relevant information to the cloud. This setup not only speeds up response times but also helps manage bandwidth and enhances privacy. The result is a more efficient, responsive, and secure system. Edge computing systems are made up of several key components. First, there are edge devices. These can be anything from industrial sensors to smartphones. Next, edge gateways act as intermediaries, connecting devices to the broader network. Finally, there's the cloud, which still plays a role in storing and analyzing large volumes of data. Together, these components create a seamless flow of information, balancing local processing with centralized resources. Edge devices are the frontline of edge computing. These are the gadgets and sensors that collect data in real time. For example, a smart thermostat in your home, a surveillance camera in a store, or a sensor in a factory machine, all are edge devices. They're equipped with enough computing power to process data locally, making them essential for quick decision-making and efficient operations. Edge gateways serve as bridges between edge devices and the cloud. They aggregate data from multiple devices, perform initial processing, and determine what information should be sent to the cloud. This reduces the amount of data that needs to travel over the network, saving bandwidth and improving efficiency. Gateways are crucial for managing complex edge environments, especially in industrial and enterprise settings. While edge computing handles local processing, the cloud still plays an important role. It provides centralized storage, large-scale analytics, and long-term data management. The cloud is ideal for tasks that require significant computing power or need to analyze data from many edge devices. By combining edge and cloud computing, organizations can achieve both speed and scale. One of the biggest benefits of edge computing is reduced latency. By processing data closer to where it's generated, edge computing minimizes the time it takes for information to travel back and forth. This is especially important for applications like autonomous vehicles or remote surgery, where even a split-second delay can have serious consequences. Edge computing also helps manage bandwidth more efficiently. Instead of sending massive amounts of raw data to the cloud, edge devices filter and process data locally. Only the most relevant information is transmitted, reducing network congestion and lowering costs. This is particularly useful in environments with limited connectivity or high data volumes. Privacy is a growing concern in the digital age. Edge computing can help by keeping sensitive data closer to its source. Since much of the processing happens locally, less personal or confidential information needs to be sent to the cloud. This reduces the risk of data breaches and helps organizations comply with privacy regulations. Real-time processing is another major advantage of edge computing. By analyzing data on the spot, edge devices can trigger immediate actions. For example, a security camera can detect suspicious activity and alert authorities instantly, without waiting for cloud analysis. This capability is vital for safety, automation, and many other time-sensitive applications. Despite its benefits, edge computing introduces new security challenges. With more devices processing data locally, there are more potential points of attack. Ensuring that each edge device is secure and regularly updated is essential. Organizations must implement robust security measures to protect data and maintain trust in their systems. Managing a network of distributed edge devices can be complex. Each device may have different hardware, software, and maintenance needs. Organizations need effective tools and strategies to monitor, update, and troubleshoot devices remotely. Automation and centralized management platforms are becoming increasingly important to keep edge systems running smoothly. With data being processed at multiple locations, maintaining consistency can be a challenge. Organizations must ensure that all edge devices are working with the latest information and that data is synchronized across the network. This requires careful planning and robust synchronization protocols to avoid errors and ensure reliable operations. Edge computing is playing a key role in the development of smart cities. Sensors and cameras placed throughout a city collect data on traffic, air quality, and public safety. By processing this data locally, cities can respond quickly to changing conditions, like adjusting traffic lights in real time or sending alerts during emergencies. This makes urban environments safer, more efficient, and more responsive to citizens' needs. Healthcare edge computing enables faster and more reliable patient care. Medical devices can monitor vital signs and process data locally, alerting doctors to any issues immediately. This is especially valuable in remote or emergency settings where quick decisions can save lives. Edge computing also helps protect patient privacy by keeping sensitive data close to its source. Factories and industrial plants are embracing edge computing to automate processes and improve efficiency. Sensors on machines monitor performance and detect issues in real time, allowing for predictive maintenance and minimizing downtime. By processing data locally, factories can react quickly to problems and optimize production lines without waiting for cloud analysis. Autonomous vehicles rely heavily on edge computing. These vehicles generate massive amounts of data from cameras, sensors, and radar systems. Processing this data locally allows the vehicle to make split-second decisions, such as braking or steering, without waiting for instructions from the cloud. This is essential for safety and smooth operation on the road. Retailers are using edge computing to enhance customer experiences and streamline operations. Smart shelves, digital signage, and in-store analytics process data on the spot, providing real-time inventory updates and personalized promotions. This helps stores respond quickly to customer needs and optimize sales strategies. Edge computing is transforming agriculture by enabling precision farming. Sensors in fields monitor soil moisture, temperature, and crop health, processing data locally to optimize irrigation and fertilization. This leads to higher yields, reduced waste, and more sustainable farming practices, all thanks to real-time insights delivered at the edge. In the energy sector, edge computing helps manage power grids and renewable energy sources. Smart meters and sensors process data locally to balance supply and demand, detect outages, and optimize energy usage. This makes energy systems more reliable, efficient, and responsive to changing conditions. Edge computing is also making waves in entertainment and media. Content delivery networks use edge servers to cache and stream videos closer to viewers, reducing buffering and improving quality. This ensures a smoother experience for users, especially during live events or high-demand periods. Financial institutions are leveraging edge computing for fraud detection and real-time analytics. By processing transactions locally, banks can identify suspicious activity instantly and respond before damage occurs. This not only improves security but also enhances customer trust and satisfaction. Edge computing streamlines logistics and supply chain operations by providing real-time tracking and monitoring. Sensors on shipments and vehicles process data locally, enabling companies to optimize routes, reduce delays, and ensure the safe delivery of goods. This leads to more efficient and reliable supply chains. Smart home devices like thermostats, lights, and security systems use edge computing to automate tasks and respond to user commands instantly. By processing data locally, these devices can operate even if the internet connection is slow or temporarily unavailable, ensuring a seamless and reliable smart home experience. Edge computing enables remote monitoring in industries like oil and gas, mining, and utilities. Sensors in remote locations process data locally and send only critical information to central systems. This reduces the need for constant connectivity and allows for faster responses to issues in challenging environments. Environmental monitoring systems use edge computing to track air and water quality, weather conditions, and wildlife activity. By processing data locally, these systems can provide real-time alerts and help researchers respond quickly to environmental changes, supporting conservation and public safety efforts. Edge computing and the Internet of Things (IoT) go hand in hand. IoT devices generate huge amounts of data, and edge computing provides the local processing power needed to handle it efficiently. This combination enables smarter, more responsive systems in homes, cities, factories, and beyond. Artificial intelligence is increasingly being deployed at the edge. Edge AI allows devices to analyze data and make decisions without relying on the cloud. This is crucial for applications like facial recognition, predictive maintenance, and real-time language translation, where speed and privacy are paramount. Rollout of 5G networks is accelerating the adoption of edge computing. 5G provides ultra-fast, low-latency connectivity, making it possible to deploy edge computing solutions in more places. This opens up new possibilities for smart cities, autonomous vehicles, and immersive experiences like augmented reality. Edge and cloud computing aren't competitors, they're partners. Many organizations use a hybrid approach, processing time-sensitive data at the edge while leveraging the cloud for storage and large-scale analytics. This synergy allows businesses to maximize efficiency, flexibility, and scalability. Security is a top priority in edge computing. With more devices operating outside traditional data centers, organizations must implement strong encryption, authentication, and monitoring. Regular updates and security patches are essential to protect against evolving threats and ensure the integrity of edge systems. Edge computing can enhance privacy by keeping sensitive data close to its source. Organizations can process personal information locally, reducing the risk of exposure and helping comply with privacy laws. This is especially important in healthcare, finance, and other sectors handling confidential data. Edge computing can contribute to sustainability by reducing the energy and bandwidth required to transmit data to the cloud. Local processing means less data travels long distances, lowering the carbon footprint of digital operations. This makes edge computing an attractive option for organizations focused on environmental responsibility. Edge computing enables organizations to scale their operations efficiently. By distributing processing power across many devices, businesses can handle growing data volumes without overloading central servers. This flexibility is essential for supporting new applications and expanding digital services. Reliability is a key advantage of edge computing. Local processing allows systems to continue operating even if the connection to the cloud is lost. This is vital for critical infrastructure, remote locations, and any application where downtime is unacceptable. Edge computing allows for greater customization of services and applications. By processing data locally, organizations can tailor responses and actions to specific environments or user needs. This leads to more personalized experiences and better outcomes for customers and businesses alike. Edge computing is driving innovation across industries. By enabling real-time processing and decision-making, it opens the door to new applications and business models. From smart factories to immersive entertainment, edge computing is at the heart of the next wave of digital transformation. By reducing the need for constant data transmission and central processing, edge computing can lower operational costs. Organizations save on bandwidth, cloud storage, and infrastructure, making it a cost-effective solution for many applications. These savings can be reinvested in further innovation and growth. Edge computing enhances user experience by delivering faster, more reliable services. Whether it's streaming video, controlling smart devices, or accessing real-time analytics, users benefit from reduced delays and improved performance. This leads to higher satisfaction and greater engagement. The future of edge computing is bright. As technology advances, we'll see even more powerful edge devices, smarter AI at the edge, and seamless integration with cloud services. Edge computing will continue to shape the way we live, work, and interact with the digital world. If you're interested in adopting edge computing, start by identifying applications that require real-time processing or have strict privacy needs. Evaluate your current infrastructure and consider how edge devices and gateways can be integrated. Partnering with experienced vendors and leveraging existing cloud services can help you build a robust edge computing strategy. Edge computing is revolutionizing the way we process and use data. By bringing computation closer to where it's needed, it offers faster responses, improved privacy, and greater efficiency. As more industries embrace this technology, we can expect smarter systems, better user experiences, and a more connected world. The edge is not just the future, it's happening now.